Good afternoon. This is Chris, and I wanted to give you some updates for the Chapter 4 lecture on carbohydrates. So you may think it's funny that we start with a photosynthesis slide, but the reason that this is such an important slide is that this is how one of the main carbohydrates that we're going to talk about is made, which is glucose. And plants can do this from energy from the sun, plus the carbon dioxide and water. And when plants make this, they make glucose. So how do we get that glucose? We eat the plants. So that's where our glucose comes from. And I bring this slide in about how this woman's freaking out that her husband's bringing home some carbohydrates. So that I hope that I can dismiss the notion that carbs are bad. So we'll learn about why carbs aren't bad. Maybe the types of carbs that people choose aren't always the best, but I'd like to review why, in general, carbs are not bad. So let's talk about the two main types of carbohydrates, which are simple and complex. Simple carbohydrates are made of saccharides. They're one saccharide, monosaccharide, or two saccharides, disaccharides. Complex carbohydrates are thousands of saccharides put together, and those two types are starches and fiber. So this gives you an example of the three monosaccharides, glucose, fructose, and galactose. So all of the carbohydrates that we eat are made up of these components plus fiber. And the thing to make a big note of is the glucose, how important that is, because our brain relies primarily on glucose for its energy source. So again, glucose is the major fuel source for the brain. The brain can use ketones as a secondary fuel source, but it's not a desired fuel source. And if you've ever followed a low carbohydrate diet or known somebody, you'll find that those people are a little bit cranky and difficult to deal with because their brain is actually not getting the glucose that they need. So glucose is the major monosaccharide in the body. And if you've ever gotten an IV, that's the chemical form of glucose, and it's known as dextrose. And for this week, I'll give you 2 points of extra credit if you email me how many calories are in a gram of dextrose. So the disaccharides are when you put two monosaccharides together. Examples of these are sucrose, lactose, which is the milk sugar, and maltose, which is the sugar that is in many grains that is used for fermentation to make alcohol. So these are an example of the disaccharides. This is in your book too. So again, the simple carbohydrates are the mono and the disaccharides. The complex carbohydrates are starches, fibers, and glycogen. And those are called polysaccharides. Okay? So in plants, there's two different types of storage form of carbohydrates, amylose and amylopectin. So for example, when we had all that rainy weather, the plants didn't get sun, but they didn't die during that time because they had stored form of carbohydrate. So when we eat plants, we're getting their stored form of carbohydrate as amylose or amylopectin. Then we also consume dietary fiber, which is kind of the structural part of the plant. Think of the celery stalks and the hull of the wheat. Those are the structure of the plant. So polysaccharides are starches, which are 3,000 or more monosaccharides hooked together. And here's a little visual of that. Glycogen is also a complex carbohydrate, and glycogen is the way that we store, as humans, carbohydrates in our body. Okay, so we have about 1,400 calories worth of carbohydrates that we can store. Majority of that is in the liver, and some of that is in the muscles. And I really like this slide. This is also in your book, but I think it gives you a really good concept of simple carbohydrates are made up of mono and disaccharides. Complex carbohydrates are many saccharides, and there's three types of complex carbohydrates. Starches, made by plants, fibers, ingestible by humans, indigestible, and glycogen, which is made by animals, and that's stored in, and this is supposed to be a little muscle tissue and a little liver. Okay? So let's talk a little bit more about dietary fiber. This is undigested starch, and there's two types of dietary fiber, insoluble and soluble. So here's a visual. The insoluble is the peel of or the hull of the food, and the soluble fiber is typically the inside. Why is fiber so important? Well, one of the things that insoluble fiber does is it acts like kind of like a rotor-rooter for the digestive system. It keeps things moving along, it increases fecal bulk. When we learned in chapter 3 about the large intestine functions, we learned that fiber is in the large intestine, and once water and other things are absorbed, then we can excrete that. The nice thing too about fiber is that all the bacteria that is in our gut, the healthy good bacteria, loves to live off of that fiber. That's what they eat. The benefit of the soluble fiber, okay, is that it actually slows the release of the chyme from the stomach into the small intestine. And what that does is it gives the body time to react in secreting sufficient insulin so that when that glucose does hit the blood, it can actually go into the cells more slowly, kind of more evenly. And the other real benefit is that it actually binds to cholesterol in the gut. And so you can lower your blood cholesterol by eating sufficient amounts of dietary, especially insoluble fiber. So again, just to review, soluble fiber can help you lower cholesterol, delay gastric emptying, and help control glucose absorption. Insoluble fiber helps increase stool bulk, and it decreases the time that food waste spends in the large intestine, that kind of rotor-rooter concept. So what's the best way to increase fiber? It's just like we had talked about in the first chapter of this book, how important it is to eat whole grains and fruits and vegetables. And these are the area, it's estimated that only 21% of Americans eat half their grains as whole grains, and 80% of Americans don't eat enough fruits and vegetables every day. So these are the areas that we really need to focus on teaching people about. So why do we need carbohydrates? Well, we need carbohydrates to help regulate our blood sugar. And so actually I'm going to skip through, I think there's a better one. In here, we notice that when dietary carbohydrates come from the stomach, so you eat a piece of toast, drink a cup of milk, you eat something with carbohydrates. Because of the amylase that's in our mouth as well as in our pancreas, it's broken down into glucose and other monosaccharides. So we break all of those bonds, and then they're absorbed through the villi and the microvilli. Once they're absorbed, they actually go to the liver. Okay, so these monosaccharides are now in the liver, and the liver can decide what to do with them. And the two choices that the liver has is to go ahead and push those glucose molecules out into the blood, or to go ahead and save some of those glucose molecules as glycogen. So if your body had a good blood sugar and didn't need any more glucose, then your body would store those carbohydrates. Okay? So once that glucose goes out into the blood, there's two things that it can do. It can be used to maintain energy for the brain and other cells, or it can be transported to the muscle so that we can have some storage form of glucose in the muscle, which actually in turn gets stored as glycogen. Okay, and the reason that this is important is that our muscles have this nice constant supply of glycogen in them, so that when hormones like epinephrine and those fight or flight hormones are released, the body immediately breaks this down to give the muscles energy, which in the form of glucose. Let's talk just a little bit about sweeteners. I don't want you to focus a lot of your time in the book on sweeteners. Obviously, we add them to food because they increase the flavor. There are two different types of sweeteners. There's natural and there's artificial or chemical sweeteners. One of the things that I do want you to understand from this lecture, and the class activity for chapter 4 focuses on this, is that added sugar should be no more than 50 grams a day. So we're going to use the My Plate super tracker, I think that you did in the first lecture for the chapter 2 class activity, and you're going to be looking at the empty calories, and the goal is to have no more than 50 grams. Okay, now if you multiply 50 by the 4 calories per gram, that's 200 calories of added sugar per day, no more than. This talks a little bit about how much sugar Americans eat. It's estimated that Americans are eating close to about 150 pounds of sugar every year. A little bit about high fructose corn syrup. High fructose corn syrup is very similar to sugar. Sucrose, which is table sugar, is about half fructose and half glucose, where high fructose corn syrup is just a little bit higher in fructose. So I personally, I don't use I'm not a big user of high fructose corn syrup, but I am not as concerned that it's this all terrible encompassing thing. I think that we need to reduce our overall sugar intake, and that means reducing our high fructose corn syrup intake. I am concerned about how much sugar most Americans are eating because it's way too many. It's estimated that most Americans are eating up to 300 calories a day from sugar, and most of that comes from drinking their sugar. So there has been some association between the increase in the use of high fructose corn syrup and the increase in obesity. I don't know that high fructose corn syrup in and of itself causes obesity. I think the extra calories that it provides when people's intake of soda and other sweetened beverages has so dramatically increased has really increased the rates of obesity. This is a good article in the American Journal of Clinical Nutrition, and it does talk a little bit about that they think the body does metabolize high fructose corn syrup a little bit differently, and it could be leading to some of the obesity that we're seeing. So again, this just kind of shows the pounds of high fructose corn syrup that has been increased and how people's weight has increased. So yes, it definitely has a connection, but is that because people are just eating that many more calories, which they could get from regular sugar too? I think that's probably so. All right, so what are the functions of carbohydrates? Well, hopefully you learned from learning about glucose that the main function is to supply energy to the brain. Okay. And thus leaving protein to do its work to build and repair, having enough carbohydrates so your brain doesn't have to use ketones, and then it also provides a sweetener. And I'll probably have to add another YouTube video because this is only 15 minutes long, so if I don't get finished, look for part 2. So let's talk a little bit about the blood sugar, which is called blood glucose. Two terms that I want you to be familiar with: hyperglycemia, which means excessive blood sugar, and hypoglycemia, which means low blood sugar. Our body really regulates a tight control of blood sugar, somewhere between about 70 and like 120. We don't really like to have a blood sugar much higher than that for too long. And the reason that it doesn't stay high for too long after we eat is that the role of the pancreas. The pancreas makes this hormone insulin, and what insulin does is it allows glucose to get into the cells, which allow that energy to be put into the mitochondria and processed and made into energy. So glucose doesn't do us much good until it's actually in the cell. So what does insulin do? It helps us store glycogen in the muscle and in the liver, and it increases the glucose uptake by the cells by allowing that glucose to enter the cells. We secrete insulin when we're eating, so when the blood sugar starts to go high, that's when the body produces insulin. And the net effect of having that hormone insulin is that your blood sugar lowers. So glucagon actually does the opposite. Glucagon breaks glycogen down. So if you haven't eaten and your body still needs some energy, we have that storage form of carbohydrate as glycogen. So glucagon breaks down the storage form of carbohydrate, which is glycogen, and it is secreted when you're not eating. And the net effect is that your blood glucose will rise. So this is kind of more of a visual version of that. So when the glucose goes, when you eat blood glucose, when you're eating glucose, then it increases the glucose. This pancreas secretes insulin, and that goes into the cells, or it's made into glycogen. And down here, down here, when you have a low blood sugar, the pancreas releases glucagon, and you start to break the glycogen down, and thus breaking that glycogen down increases the glucose in your body. Okay, I'm going to skip through the glycemic response. There is a discussion on the glycemic response that you can look at. And we did talk about dietary fiber. I'll go through these a little quickly. And the importance of soluble fiber for cholesterol. And I'm going to go ahead and stop here, and then I'll redo part 2, starting with carbohydrates in foods.